So this is okay? Yes, good. Okay, let me just start with a little movie here. But welcome here to IBM.
Denmark is at the forefront of a global change in energy efficiency. It has set itself a goal of becoming a CO2 neutral country by 2050. The political willingness is there, and technologies such as smart grid promise to deliver a low-carbon society. However, shifting from consumption-driven power generation to production-driven electricity poses some serious questions. How can we minimize the business uncertainty that comes with relying on more fluctuating energy such as wind and solar power? Could the key be in the hands of the consumers and their willingness to be flexible in their consumption? Can we acquire this flexibility and trade it as any other commodity to make the system more efficient?
iPower is a research program that develops tools to control millions of flexible consumption units. The concept is to turn power consumers into suppliers of flexibility.
Here's how it works. Consumers set their consumption limits. They decide what their comfort zone is and voluntarily offer their flexibility in exchange for savings on their energy bills.
As we're speaking, we have 5 projects running where we're buying customer flexibility. Financially, that seems very promising. Apart from low prices, the key focus is certainty that customers are flexible when and where we need it.
A professional helper, or an aggregator, gathers a portfolio of thousands of these flexible consumers in what can be compared to a mutual fund. Large consumers of power can also join their local aggregator.
We are already mobilizing large consumers to serve the TSOs, services markets, and we are quite open to also serve the distribution grid companies as well.
The grid infrastructure owners, or DSOs, and the aggregators meet at the Flexibility Clearinghouse, or FLECH. FLECH is a market-based platform. Think of it as an auction house. At FLECH, the DSOs post their demands for local flexibility. Aggregators have this local knowledge and compete amongst themselves to supply these demands at the lowest price point. The winning bidders are awarded the contracts. When the need for flexibility arises, the DSOs activate their contracts to divert the load as previously agreed upon. The delivery of flexibility is measured and payments are made accordingly.
Another advantage of FLECH is that the participants are held accountable for their contracts. That certainly increases the trust to the market platform.
Systems like FLECH are already being implemented successfully. In the United States, the largest aggregator optimizes 7,000 megawatts of power. That's more than the entire Danish peak load.
Distribution companies and retailers should take a close look at this. In iPower, we expect that this will provide significant value in the future.
Everyone is invited to participate and shape the future of energy distribution. iPower helps create our new energy future.
Yes, so welcome. This was a movie that we where we launched the concept of FLECH last year at the Energiens Topmøde in June. And this gives you a highlight of what we're going to talk to about today. But first and foremost, welcome on behalf of iPower and DTU, Dansk Energi and ourselves, IBM here, and welcome to IBM. We're very happy to see so many people. And just to say that the interest is very big, and we have had people asking from abroad if we could broadcast this also. So it seems that we have got, we now have gone in the right direction with this development in iPower as one of the deliverables in iPower. So we are into the 3rd year now of the iPower project. The iPower project started in 2011, will be done we think end of 2015, and beginning of 2016. And the aim of iPower is to develop an intelligent power system where we can do more production controlled demand instead of the demand controlled production that we have today. So this is a SPEAR project. So this is strategic partner in innovation and research. So it's also an innovation project, which means that that in this project we are allowed to actually develop products that can be marketed. And we think that that FLECH here is one of the deliverables, the many deliverables from the project that could go and become project that we can actually find a market for, given the interest we are seeing. It's also building on the experience we have from and the partners have from other projects like Forskel, various EU projects like the Edison project, and also I would say partly from some of the things that are being done in the EcoBit project at Bornholm right now, and you'll hear more about that later. So as I said here, we are trying to link research, demonstrations with product development and develop methods and technologies and requirements for a future smart grid to be able to also utilize some of the flexibility in the grid. So FLECH, which stands for the Flexibility Clearinghouse, as I said, is one of the major deliverables in this project. And it's an important component. This is where we will see if we can surface flexibility, and you'll hear more about that. I know most of you are very proficient in grids, and you have many engineers here, so you probably know it. But you will have an introduction to also what we mean by the flexibility and what we mean by the smart grid, just in case. But it's a milestone today. We are, I would say, half in the development of the FLECH. So what you're going to see today is a demonstration of proof of concept, of a mock-up, you can say, and we will continue development for our next event, which will be in November, and we'll come back to that. So with that, let me introduce the agenda, which I haven't seen. I won't go through it in details right now, but very important. There will be a coffee break at 4:30 with some cake, as I promised in my mail yesterday. And as I said, we have the Q&A panel here. We are video recording everything here, and the slides will be available also on the iPower website. So I hope you are okay with the video filming, because we have had so many requests from other places also if they could see what's going on here. So with that, I think I will introduce Rasmus and hand over the mic here.
Yes, I will spend a few minutes on introducing iPower in general. I work for TTU, and it is correct, as Anna said, that FLECH involves DTU as a primary partner, but I think it's actually relevant to stress here that IBM and Dansk Energi and Danish Energy Association together are developing FLECH based on research and fact-based approach from Aalborg University and DTU. So I really like this approach, that we do some research at the universities and then we work very closely together with these three partners to actually productize it. I'm actually very happy today to see such a diverse audience. I see people from many different parts of the industry. I see people from energy component industry. I see people from distribution industry. I do see, of course, a lot of you guys from the universities. I think this is really great that we are such a diverse audience for this. I hope today, Anders, that we will all learn in detail about what FLECH can do, and then after that try to understand how can FLECH help us in our own businesses to improve the business, because FLECH is actually quite difficult to understand. I change my understanding of it myself occasionally, so I hope today that we will all reach a relatively high level of knowledge on what it is. But a little bit about iPower. We are working in a number of areas. Today we present this one, the flexibility marketplaces, which is one out of 5 separate areas which together form the smart grid research in this iPower project. The other areas is flexible consumer demand, where we focus a lot on residential houses and the heating comfort, and how can you have a house flexible but still keep the heating comfort. Then we have the industrial demand response, where we use industrial applications such as supermarket cooling systems and air conditioning system to provide various flexibility products to the electricity grid. We have research on actually making the distribution grid smart, the 10 kV grid, the 60 kV grid. How can we add sensors and use the data and so on? And then today we work with the flexibility marketplace, and then we also have some work and research related to the general economy on this, both the economy for the individual actor and the economy for the society as such. Another important aspect of iPower, which you already mentioned, is that it is actually not primarily a research project. We have quite a few research activities where the universities and the industries work together, and this is actually a key element of iPower, which is a bit different in some other research projects, but here it's really a goal that the research leads to some product development. And the underlying aspiration here is that those companies, industries who take part in this get a cutting edge with respect to the utilization of this technology. Just briefly, we are approximately 35 partners. There's not 6 million euro, but 16, so 120 million kroner. And we are well on our way, and will probably end around end of 2015, and then a bit sum up in 16. Partners go, partners come. May I mention that we just recently said hello to Metro, and we are thinking about inviting in another partner from Jylland in Zero Software. So there is a bit of going in and out, which corresponds to the fact that the project is quite long. Just a little bit about our next potential partner, which we will discuss at our General Assembly here in May. We are starting up collaboration with Zero Software, who work with aggregation of residential buildings, and are planning a smart business house near Vejle, and have a collection of houses near Horsens, which are being used for residential smart grid demonstration and experimentation. Finally, I want for iPower just to highlight the next few activities. In a little more than a month, you are invited to join us for our 2-day conference. You can join for the full part of the program, or just the parts that suit you. This year we will be at the Aalborg University, Copenhagen, and I think we have a pretty interesting program. For example, at the end of the 14th of May, we will see the R&D Vice President of Saint-Gobain, which is a French company, and creates building materials, and this is extremely interesting topic also when we migrate from smart grid to smart energy, to understand more about building materials. So if you haven't already gotten the mail, this may be of your interest, and it's should be easy to remember how to register. And then the whole big picture, we hope to have it ready for you for demonstration in November this year. Anders just promised to have FLECH ready, and I can therefore safely make a FLECH box here. We have a lot of other boxes of products, which we actually intend to spend 2 days in November to do interaction between in reality. It will be so that we will spend a full day actually again on FLECH to really try to walk through it, so that people can understand the business potential of FLECH. And then we will spend We have a major deliverable from Aalborg University about a so-called heterogeneous aggregator, which is a scientifically proved way of spending your energy optimally in a flexible environment. We were going to spend a lot of effort also to show this to you and actually do it for real at the Syslab at Risø. And then we will finalize our package of research and demonstration within the residential smart grid. We are looking really much forward to this very practical demonstration in November. There will also be something next year. All the economical aspects, we are still not ready with that. Headed by Danish Energy Association, we are trying to sum up what's the economy in all this, and we hope to have that ready for you, and that will not be until the end of 2015. But at that time, we do believe we have a very substantial result for you to present. How is exactly the economy of all this? So this was what I intended to say about iPower as such, and yeah, is it a question or is it on?
Yeah, there's a minute for question if anyone wants to question. No, doesn't seem so.
Good.
So let me introduce Dieter Gantenbein. So yes, Dieter is a technical project leader from IBM research side in the iPower project, and is also leading many of our other activities in the smart grid area. So Dieter, with that.
I need the remote control. So we are very happy that we can participate in the Danish leadership in the area of smart grid. We are in Zurich and we have less wind, and the vision to be without nuclear power, the vision without too much oil in the electrical power system is such a tremendous vision, where Denmark has led since the 60s. And when we decided we wanted to do more in the area of smart grid, Denmark was for us a natural choice. For IBM, it is always the analytics, the data. It is not the actual soldiering of the real-life things to the cloud. It's the cloud side business which is dominating. I took this picture myself on a bicycle between Hamburg and Frederica when I wanted to see the Danish countryside, and I bet I have never seen so many hares in hopping around the prairies in my life than that day. In IBM, it is about globalization. So the only thing local is our customers, our business, but it's a global strategy. So all the labs have their speciality. Dublin and Zurich are indeed very strong in smart grid, and other, apart from our headquarters in New York, and we also have strong plays in China and in India in smart grid, many projects. The smart grid is something completely different. In each geography, smart grid means something else. In the US, if you expect the next thunderstorm and you want to make sure that wherever the thunderstorm hits the next wooden pole along the highway, so that the power engineers need to rush with their trucks and put the new pole up, if you can predict where the next pole will collapse and you can ready the workforce to that area, this is smart grid. It's analytics. And in China, what we have is a project that starts micro weather prediction supported with cameras. So you essentially look at the sky, look at the patterns of your clouds, and you try to predict in very short term resolution the summary generation of green power from the sun, And then in Malta, which was in the Mediterranean, which was our IBM first smart grid project, it was more about fraud detection, smart meters helping to board the illegal consumers to an official bill payment cycle. And so smart grid means so many things to many people. In IBM, some say it's get out of the eroding margins in the data center. Some call it the smarter planet. The marketing people are very strong that the Earth has finite resources and that some optimized use of them is to the benefit of all. Applied to the smarter energy, it is about the grid. We all have our we have our heart pulse or our location of humans. It's all going into the cloud. So why would the grid still be analog? I think it deserves to be as digital as the rest of the world, and the data from the grid can be used to optimize it. And some parts of the taxpayers, they also deserve to know where the taxes go. They want to provide, let's say, flexibility in their operation. They are willing to consume a little bit less, but they want to know what's going on, so they want to be part of the loop. So the humans being always connected, the grid being always monitorable with all the way into the low voltage area, and then the opportunity to time shift flexible consumers, enabling the aggressively fluctuating, dynamically changing green energies, photovoltaics, wind, etc. This goes hand in hand, and on those three pillars many smart grid projects can be defined. IBM had in its early smart grid coalition the Danish company Dong as one of the early collaborators, and that has given us quite some mileage. That was a very good move to have this partnership. And the Danish Edison project, where I partially participated from the beginning, was an invitation to bring information, communications, technology, computing into the grid, playing it out on the island of Bornholm. Of course, we have many more projects worldwide, but definitely, as you can see from left to right, Denmark is on the map. If you look at smart grids, as part of the energy system, there are many facets. There is the homes, there is the office spaces, the building, the residential areas, the industry, there's the transport that interconnects it all, and of course the typical grid players. And when you optimize, you can optimize in the planning phase, 5 or 10 years before you need something, or you can do it more close term. In Singapore, there are projects where they say if the train gets stuck in the tube, power outage in the morning, maybe the train has a problem, not the grid, of course, then where do they need to park the spare buses such that the end-to-end delay of the people leaving home wanting to reach their work can be optimized. So minimum time to work despite failure, n-1, that's leading to the planning of the best places to put up living quarters, dwellings. It's leading to the best locations for subway stations. So at this 10-year ahead or 5-year ahead planning cycle, all these different disciplines like transport, distribution grid, and all of those aspects have to be intertwined into an overall understanding. Some call it simulation. And then, of course, the requirements on the ICT system, they grow when you want to do this in real time. I mean, unclear whether in the future you will look at your mobile phone and say, I need a rare steak, so my energy consumption is very small. I need a parking right in front of the restaurant because my wife has no umbrella. And then the system will give you the best choice. So the good food, the lowest energy, the shortest time, and you're bypassing the areas of town that have congestion, and you're solving everything in a spatial, temporal space in real time. I think we're far away from that, but probably that's at least one way to articulate the vision. IBM is moving heavily into the consulting, into the IP services business, and one play we have is the so-called Smarter Energies Area Research Institute. It's run by the research division, and it is basing on the needs to have better materials, let's say batteries that weight less, so lithium-air batteries is one challenging research direction, or then machine-to-main system solutions. How can you interconnect millions and trillions of things such that the cost of energy of maintaining that data is less than the savings? And then it's the core area of analytics and optimization. So everything must be connected. You need a few good hardware-based inventions. And then, in particular for the smart grid, those are a few application areas. So it's a US chart, the Department of Energy having enormous wealth of projects overall in the world. But it's good to see that at least Denmark is recognized, and IBM is very thankful to the Danish society that we can participate here in this innovative way forward with renewable energies to a large percentage. Of course, when we talk about energy, it's not always electricity. You may be all electrical engineers, but there's more than that in life. So, water-cooled, just think of the traditional IBM business. We are known for servers. The servers, they come in pizza plates, you plug them into the racks. But while it has been in the past, the three-dimensional building of servers has been done, what's new here is you see water going to the CPU along those copper blades. And this allows, instead of having a huge auditorium chilled down to 10 degrees, like in the Danish spring, and then the computers having a minimum requirement that the silicon should not heat up to 300 degrees. It is optimal if it is below 100 degrees. So why do we need to chill the air if the purpose is to cool the processors? So in this system that has actually been pioneered in our lab in Zurich and deployed to Leipzig, one of the largest German data centers. Also ETH Zurich has a productive server. We bring 60 degrees hot water into the server to cool it, and then the output is even better, and it can be used for district heating and the like, or in some geographies where you don't need to heat, you would rather do desalination. So the idea that half of the energy bill of a data center can be eliminated just by smart reengineering. So it is not always about electricity. It starts at a much wider angle. That's the point trying to make with this chart. And then more towards the smart grid. As we said, we want to involve the users, the participants. First is to have an insight into what's going on. And then with respect to the integration of renewables and zero emission, you need the response. And at the end, if you optimize right, there's a win-win where at an economic level, many of the players can benefit quite well. And it has to be done efficiently. And I mean, talking to you, iPower people and iPower associate partners, I think iPower has tremendous potential to come out with a worldwide unique, new product, architectural thinking, and more to come. But it fits our 1, 2, 3, 4. The question is, what is 5, 6, 7, 8, 9? So if I just quickly drill into what in our Zurich research team, what we have done with respect to smart grids, we had the chance to participate in Edison with the electrical vehicles that didn't come to Bornholm, and so we simulated a few. Then iPower about the overall optimization landscape, morphing a little bit into more the market space in recent years. An EcoGrid about a new concept where an economic concept would be injected into smart grid, which is the grid historically being electrical engineers only, not market specialists, but maybe the grid in the future could be operated in an economic way, and I think that's also how the two projects 2 and 3 connect. And honestly speaking, while we have still not all of us learned how to speak Danish, at least our participation in Denmark also brought us a few interesting projects in the Alps, in Switzerland, and being frustrated with so many individual households that all have their particular situations, like a smart home with a heat pump, the efficient Dane would just turn off the internet connection at night, and then IBM could no longer do demand response on the house. So being a little bit frustrated with some of that, we tried out a huge freezer house where a single freezer house could give 1 megawatt yield, and also had some interesting lessons there. And so overall, we built up some IP and a reusable asset that we are dedicating into the global IBM, and we call it the flexible energy optimization system, and you'll have a chart on that in a moment. So if we spend just a second to drill into 2, 3 select projects, you know, the consumption and generation and the morning and the afternoon peak, and many of the needs like heating and the driving, car driving is related to the human. So the morning Nespresso and the evening peaks, they get just wider and higher with additional applications being boarded onto the electrical distribution system as the most efficient energy transport. And then Denmark has this great idea, maybe not first in the world, to have dynamic prices. And what we did in Edison is we showed that if half an hour cheaper power happens a little bit, let's say it's 3 o'clock in the morning, there are definitely some smart Danes that have a timer, and they will decide that their car charging will start right around the clock on the hour, and therefore we have worse spikes than what we had during the day. Whether that is easier to balance when at night the central power plants are typically not needed and would need to ramp up immediately. So obviously A, B, C is optimal. C is with the IBM data and optimization in the middle. What else could be the conclusion? But the point is, first of all, we can do the car charging at night, and during the day keep the central power plants much more stable by doing the dynamics with the demand side management. So it can be done. But on the other side, the real insight we had with this project is, of course, IBM can simulate the entire island of Bornholm, power flow simulation, traffic injection in 5 minutes on a portable computer. But where's the privacy? Where's the privacy of the driving, the privacy of the household? Do we always get all of this data into a single computation? And does it scale to Denmark and to Europe? So those are the questions that please remember when we move into other projects. With car driving, it's also a question how you connect. So is this thing compatible? So, as a kind of morphing of the Danish Edison project, we did the Swiss project with the Zurich utility, where we said the energy into the car should be a normal plug. It doesn't have to be aggressive. It should be at home and at work and maybe on the highway when you're running along some well-defined track inductively. It can be slow. The energy doesn't have to flow intelligently. And the way the humans are connected to the cloud, and the humans are not connected to a charging spot. The humans are connected much more flexibly, and the cloud interconnects it all. So why couldn't it be that the car, which is anyway already connected to the OEM, to the car manufacturer's cloud, why couldn't in the cloud the homogeneous virtual power plant of cars just have an interface to the utility? So if the human wants to see what's happening with his car, he can also see the battery is enough full for his next trips. Then he can delegate the flexibility to the cloud, and then they can negotiate when the car should really charge. And in this way, you don't need to instrument the car. The OEM does that already, and the fleets of cars, they can negotiate their things. Maybe the more modern version of this picture would have FLECH there instead of VPP. So I guess the point is there are all kinds of pre-aggregations going on, and all kinds of flexibility that can be exploited, and it will not happen the way that the initial things happened, that we standardize now charging spots with intelligence, and as soon as you screw them to the ground, they are obsolete. I think the cars and the mobile devices, they are the future, and they're innovating themselves in a much faster pace. Here you see an example of the state of charge from 100% down to the minimum of 25 over 2 weeks in a car my family drove, and we artificially changed the speed of charging to 7 ampere max, and you can see over the multiple drives in red and multiple days from weekend, the state of charge dropped, and then before the weekend some creative taxpayer said, I'm not going to charge at home, the company can charge my car. So here's the first time where the car was put into charge me now immediately mode, and before it was all automatic. The IBM server was deciding when there is local photovoltaic in Zurich, the battery gets charged. And in that sense, it brings us to the analytics optimization things like you want to do things not generically, but with a certain sophistication. And first of all, you want to describe the system, but then you want to predict what the system does, and at the end you want to control the system, but in a model-based way. So I think iPower is very much focused on these analytics aspects of models, and eventually stochastic models, and this will allow the global optimization, and that's the challenge, to really optimize more and more, to have enough communication, have efficient, cheap communication, and with all the data you have, be able to optimize it. And that's why we are very happy in iPower, and maybe it lasts a little bit longer, we hope. In any case, the markets for the power system get challenged with the renewables. There are the slow pre-day and the balancing market pre-the-hour, but as the need for kind of short-term rebalancing increases with the renewables, there's a vacuum of need that the automatic control that in the past has been maybe 10% of the installed capacity, in a very bad wind or non-wind day might really get challenged. The 10% is by no means enough. Then maybe some economic mechanisms to get demand side participation might be worth it. So in this EcoGrid project, we study a 5-minute market for the TSO, for the overall Danish balancing, or east or west balancing very globally whether demand side could live up with its flexibility and participate. And the beauty of this compared to the previous Edison, where we said we can compute all of Bornholm in 5 minutes, but we need all the data from you and me in one box, and who wants to give that data? So the beauty, the creative idea of EcoGrid is that at the national level, you say we have too much power or not enough power in the next 5 minutes. You say the marginal cost of rebalancing is the price incentive we send out, and it reaches the same way a la newspapers. Not each of you has an individual newspaper. We can have classified newspapers for each target group, different distributions. Different areas might get different prices, or different situations in a feeder might get different prices. But the individual that reacts with its price agent to the new grid situation does not have to give its privacy up into the cloud, into the total control of Big Brother Orwell watching you. So this is both with respect to the distribution of the grid incentive, a step forward, and also with respect to the potential privacy issues, much better approach. And if we generalize the individual households and cars, they can be pre-aggregated, and then there's the classical market. There are, let's say, the EcoGrid 5-minute new market for the TSO. But then there is a vast opportunity for new economic handling of capability, also at the TSO level. So that summarizes like this. There's lots of markets at the TSO level, and at the TSO level there are a few business cases, peak congestion, voltage issues, that could help, and there's not enough support economically. It's all locally, technically done. And so the question we ask is, there's all these TSO markets, maybe even the newer 5-minute real-time markets, and at the distribution level, what is the economic way that flexibility can be matched, maybe in a clearinghouse, with those that can benefit from the flexibility? And the claim, the hypothesis, the vision of all of the iPower group is that at the DSO level, we need a new market and clearing mechanism. And of course, it's a very tight integration with the TSO and the DSO needs, but it's innovative in this white space. And it's about the individual and aggregated flexibility being made available to a more efficient handling of the grid, to allow higher integration of renewables. In IBM, in our team in Zurich, we have initially thought it's all about the virtual power plant. Virtual power plant has 3 levels. First, it's the device model, like the heating, the house, the modeling of the heating needs of a house, the driving needs of a car, and then the aggregation up into a pool, and then a strategy layer where at the strategy layer you would integrate. But then by participating with iPower, our architecture morphed, and we created this standalone FLECH, joint with the partners, where it's a clearing, so the virtual power plant can have multiple options how to play, and it puts them all into this white space painted blue, and then the TSO and the DSO players, if they want to grab some of that flex for their economic balancing, they can do. So the strategy layer of the VPP doesn't need to decide, so it's really optimal. The decision happens globally, and so this is the new architecture. So in summary, and this is my last chart, smart grid, it will help renewable integration, and it's more efficient. And the economic approach to the smart grid, it is not replacing today's grid balancing mechanisms, it's complementing them, but the focus on economics is the way to go. it's feasible. In particular, if it's supported by what's already there, and it gives the right momentum and signals. And of course, Denmark has a mandate here to continue its leadership. Is the regulatory conditions must be readied in time to show the world how this can be done in a futuristic way. And in this way, we hope that this tiny plant in some parts of the world, the smart grid is still very small, and Denmark it's already big, but it will unfold, and that's what I wish for all of us.
Thank you. Thank you, Dieter. I think there'll not be time for questions now, but as I said, later there will be time. So while they are exchanging the infrastructure over there, so let me just introduce David Tacky. David Tacky is an electrician and electrical engineer also from Dansk Energi, senior consultant. And you will tell us a little about how you look at how Dansk Energi looks at the challenges we will have for the DSOs and the congestions we're looking at, etc., and what needs to be done. So with that, David, please.
Thank you. Yes, so my agenda for today, very short, these 2 points. We'll talk about the future challenges for the DSO and if smart grid, if that could be the solution. So, first of all, smart grid. I've noticed when I talk to different people from different domains and we talk about what smart grid is and what smart grid should solve, I get very different answers. For example, when I talk to Energiens DK, the transmission company in Denmark, ask them what is smart grid, what should smart grid solve, they say smart grid to solve the problem when we get more renewable energy resources, it should help us keep balance of the production and the consumption at all times, so the frequency level is stable, because that's their main concern. So that's what they will answer. If you ask the consumer what smart grid is, many of them probably don't know, but if you ask me as a consumer, I think the grid we have today is very smart. Every time I need some energy, I just plug my device in, and if I don't need it anymore, I just plug it out. So as a consumer, I think it's very smart, the grid we have today. But here I will zoom in at the DSO as the distribution company and look at smart grid from the distribution company's point of view. So what is the distribution company's main responsibilities, main issues, main challenges? They're responsible for the infrastructure at the low voltage level, at the distribution level, and they need to make sure that you can supply the energy needed for any given household at any given point of time, no matter how much the consumer demands. And that has been a relatively easy task for many years, because when they're doing their planning, they can just calculate how much will the consumption increase throughout the years, and that has been relatively stable, maybe 1%, 2% in some area. So it's been very easy for them. But in the future, this can change completely, because if people get new consumption units that consume a lot of energy, then suddenly the consumption increases and they could create problems for the distribution grid. So, talking about some of the challenges, you have some of them here. The Danish politicians, they have set some very ambitious goals for our CO2 emissions and how to bring it down. So they want us to, is it better now? Okay. They want us to reduce our CO2 emission by changing the way we produce energy from fossil fuels such as coal, gas and oil until renewable energy resources produced from, for example, windmills. And when we make that change on the production side, we also need to make some changes at the consumption side. That means that we need to change this old car that runs on gasoline with this new electrical vehicle. Maybe not this model, it's from better place, they don't make those anymore. And you need to change the oil-fired boiler with a new heat pump. And these two units is just examples of units that consume a lot of electricity, so you can use it for these renewable resources. But it can also create issues and challenges for the DSOs. And I see two main challenges that the DSOs are facing. One of them is voltage issues. If you have a transformer station and a feeder along the way, every time you add some more consumption, the voltage level will drop. And usually you solve it by rising the voltage level just a little bit at the starting point at the transformer station, and then you can stay within the limits, the lower limit at 10%, but also the top limits at 10%. But the problem is when the same consumer take his electric vehicle, drive to work, and have photovoltaic panels on his rooftop, then he starts to produce energy. And when you produce energy and you produce more than you use, then the voltage level starts to rise. And that means it's going to be more difficult in the future for the DSOs to stay within these limits, this voltage band of plus minus 10%. And we have seen what happened with the photovoltaic systems in Denmark. If we just look at the year 2012, we went from having almost no photovoltaic systems, maybe a couple of thousands, to more than 70,000 alone in year 2012. Due to some regulation, it has evened out quite a bit, but it just shows how fast it can go with the consumer see, okay, here's an economical benefit, maybe an environmental, but I think the economical side has shown that it can go very, very fast. And I don't know what the next boom will be, but when it comes, it can create big problems for the DSOs. So let's say it's the electric vehicles or some other kind of consumption units. I think many of you have seen this drawing before. This shows the consumption throughout a feeder from the early morning hours to midnight. And it shows here that around 6, 7 o'clock in the evening, the consumption is at its peak, call it the cooking peak, because everybody comes home to make dinner and use a lot of energy. And if the new energy you are going to use from electric vehicles and so on is put on top of that, it could create issues. So the DSOs want to find some incentives that can remove the energy or put the new energy in other areas than in the peak state. And actually today the DSO have only one choice if they have a congestion problems. They need to reinforce the grid. So congestion, they need to reinforce. So that's the only choice. In iPower, we would like to give the DSO a second choice. We would like them to have two choices or more, at least two choices. So one choice is to do what they always have done, is to, if there's a problem, we'll dig up the sidewalk, put down new, stronger, better cables, and we'll fix the problem. But in other cases, it could be more economical, it could be a better technical, economical, optimal solution to use smart grid. Where you maybe ask an aggregator who have the contract with a lot of customers to get them to reduce the energy during peak hours. So we're not saying that in every case you need to do the smart grid solution, but the DSOs need to have the choice and need to calculate in a specific case what is the best solution. Is it to do as we always have done, to reinforce the grid, or is it to find a smarter solution? And I know some of you say that, yeah, but the market for the DSO is not quite there yet, it's not up and running, so do we only have one choice? I would say no, there's still some smart solution that you can do today as a DSO. you can decide to install measurements in your grid so that you get more knowledge about the energy that is consumed in the grid. Because today, most low voltage grid is just like a black box. The DSO doesn't know how much energy that is consumed in any given point of time. So if they just get more information about the grid, they can use it more efficiently and get closer to the capacity limits. And this is what we have shown in the iPower project. We have made a demonstration. What we done was that we took one of these black boxes, one of these 1004 kV feeders, and we put up measurements everywhere. And every consumer got a smart meter. Every cable cabinet, we put in measurements at the end of the feeder. Everywhere there was room, we put in measurements. We put in measurement units. So we got the complete picture of what that feeder looked like. 100% clear picture. But we know this will never happen in real life because it's just too expensive. But we did it anyway to get this clear picture. What we did afterwards was say, okay, now we know the answer, 100% what it looked like. Then we'll try to only use the information from some of the meters, maybe 2 or 3 meters in certain areas, and say, okay, how close can we get to the reality? Only using the information for 2 meters or 3 meters. Maybe we'll not get the 100% correct picture, but maybe 80% or 90%. Maybe we can get close enough. So this is what we have tried to test here, and then you can see how close you are comparing with all the real measurements you got at every point. And I'll not go further into detail with this, but if you want to hear more about it, this is some very exciting stuff. On the 13th of May at the consortium meeting, one of my colleagues will go more into details about the results here, so look forward to that. My last slide, just to sum it up, the challenges for the DSO. I see these 2 main challenges. The one is the voltage issues. The other thing is congestion and how to manage congestions. Is smart grid the solution? Yes, in some cases we need to use smart grid, more measurements, help from the aggregator. In other cases, we just need to do what we always have done, and that is to reinforce the grid. Thank you very much.
Questions, comments today before coffee? No? Okay. So we will have 15 minutes coffee pause, and we'll just be outside the door. So please be back at 1:45.
Rummet lidt, ikke?